Alrighty. So area, we're gonna start today with rectangles, squares, parallelograms, and then triangles. And so I do think that you will know these formulas already. So if we are being asked to find the area of a rectangle or a square, we hopefully all understand that that is base times height. Now, a parallelogram can literally come from this rectangle kind of just being shoved over until it leans. Okay, so it's just like a leaning rectangle. And if I draw in the height right here, the one thing that I have to make sure of is that my height is in fact perpendicular to my base. So that's something to keep in mind, that the height should be perpendicular to the base anytime you're using the formula. So in a parallelogram, it's really the same formula, base times height, but I kind of want to prove to you why. So let's say I take that green triangle, see if I can pick it up. There it is. And I move it right over to here. And I'm covering this up because I took it away. What shape do I have? A rectangle, right? So if I cut off that leaning part of the parallelogram and I just move it over here, I've got myself a rectangle. So that is a kind of a proof as to why we can say that the parallelogram formula is also base times height. Something that you should be aware of is that we like it. It makes the most sense to us when the height is drawn like inside the shape, but it doesn't have to be that way. The height could be drawn out here with a dashed line. So height could be here. And when that happens, there is often also a dashed line going this way. That is not a part of the base. Okay, the base is only the original base of the parallelogram. This is an auxiliary line that's just kind of coming out to the height. But you'll see those because sometimes this right triangle might be like a special right triangle, like a 3, 4, 5, or something like that. All right, so there we go, same formula. So then let's take a look at this tricky little shape here, right? Is your ticker ticking? Yeah. Uh-huh. It's a 10. All right. All right, we need to focus on RSTU. There's several shapes here, so I'm gonna highlight RSTU. And I've got myself a parallelogram, right? It's not a rectangle. And I think I could go ahead and call this the base. But if that's the base, is 25 the height? No, the 25 is not the height. The height has to be here. But good, you are seeing it. Sometimes you have to look outside of the box. See what I did there? Look outside of the parallelogram. Yeah, okay. So that is a 20. So our area is the base, 35 times the height, 20, divided by 2, right? Hold on a second. Like, wait, what? What? What did I do? What? You're right. That doesn't get divided by 2. All right. So what is that? That's 700. And we're going to call that units squared. If it doesn't have units in the problem, please do include units squared. So then let's see, this one, we've got ourselves a parallelogram. I think we could absolutely call this the base. But if that's the base, this is the height. And we don't know that. But notice that the height is a part of a 30, 60, 90 right triangle. So we got to go back to chapter 7. All right, yeah, little math rewind. If the hypotenuse is 10, right, that's the 2x. The side across from the 30 is the x, and this is the x root 3. So how big is x? 5, right, because 10 equals the 2x. So x is 5, so therefore I just found out my height. So area is base times height, so 20 times 5, so 100 units squared. Now I want you to think about all the ways that we could vary this problem a little bit. Maybe instead of the 30 being here, the 60 is here. Maybe instead of a 30, 60, 90, it's a 45, 45, 90. Maybe instead of it being a special triangle, maybe it's got a 37-degree angle. This is 10, and you have to find height. How are you going to do that? Trig. Hey. Which trig function would you use here? Here's the angle. Opposite over hypotenuse. This would be sine. Okay. Now, here's the good news. Okay. This might cause you a little momentary pain, right? Oh man, I have to remember that. The good news is reviewing for this semester's final exam is really easy because we keep using the stuff. We keep using chapter 7. We used it in chapter 8. We use it in chapter 10. We use it in chapter 11. So it's like you don't need to review chapter 7. So no proofs. All right. Do you know why the area of the triangle is half the area of a rectangle? Two triangles make a rectangle. How about we take our rectangle, we draw a diagonal, and look at that, I got 2 different triangles. Okay. Hopefully that's a good enough proof for you. I do want to let you know that sometimes I prefer to write the formula like this: base times height divided by 2. Okay, these are exactly the same. So I just don't want you to get confused if I do divide by 2 instead of multiply by 1/2. Those are the same. Yeah, it's like a backwards 3. All right, so something like this, the entire triangle, you're gonna like pictures like this. This is pretty basic, right? You've got a horizontal line and a vertical line. Great. This can be your base. This can be your height. So area is 8 times 21 divided by 2. Now, I'm not going to reach for my calculator right now because I'm going to reduce this 2 and reduce this 8. So I get 84. But you can reach for your calculator. It's okay.
Still unit squared?
Yeah, it's still unit squared. Okay. For this one, it's a right triangle. Do I have the pieces that I need? Let's see. If I call this height, then this is my base, but do I know what it is?
12.
I do, because it's a special Pythagorean triple. Okay. Keep in mind, maybe it's not a triple, and you have to do the Pythagorean theorem. Okay, that might be a situation that could come up. So the area formula is relatively simple, 5 times 12 divided by 2, but you might have to do a little legwork to find the missing pieces. So what is that, 30 units squared? Great. Okay, So something like this, let me get rid of this, get this out of the way. Okay. So something like this, what I need you to start thinking about is maybe rotating your head sometimes. In this particular problem, I know 2 of the 3 sides of the triangle ABC. Then these are auxiliary lines. If this is what I choose for my base, so if I say that base is 8, this is what needs to be the height. Okay, and Sammy, what would it be?
It would be 4, because the 3 and 5 would make up a triangle.
Exactly. So sometimes you might have to do a little bit of, right triangle magic to figure this out. Yeah.
Would you also have to add the 3 to the 8?
Okay, good question. So this 3 is not a part of the triangle. Because of the dashed line, it's an auxiliary line, so it's not the base of the triangle. Okay. So the base is 8, the height is 4, and so the area is 8 times 4 divided by 2, so 16 units squared. Now, what I want to show you here is that sometimes this may be like this. Like maybe it's typed on your page like that. And if it's kind of given to you like this, your natural inclination is going to be to use this as your base. We like it when our bases are horizontal. Our brain just finds that normal. But I don't have the height in that situation. So if you find yourself looking at the picture and going, I don't have the 2 things I need, consider rotating it. And maybe the 8's supposed to be your base, or maybe the 5 is supposed to be your base. The base of the triangle is half the height. The area of the triangle is 64 square centimeters. Find the base and the height. Could you just guess and check? I mean, you probably could just start guessing and checking. That would not be the most efficient way to do this problem. Because what if it's some decimal number and not like a whole number? So why don't we start here? The base of a triangle is half the height. Can we write an equation from that?
Yeah.
Okay, so base is half the height. Now, we know a formula for area. We know that area of a triangle is the base times the height divided by 2. So, we have some substitution to do here. Can't we take a b, and any b could be replaced with half h? We also, let's see here, we also happen to know that the area is 64, so can't we just replace that as well? And then you only have one variable. So 64 is equal to, this is going to be half h times another h divided by a 2. All right, algebra. Let's see what we got going on here. So 64 equals half of h squared divided by 2. If we have a half and then we divide it by 2, what do we get? 0.25. We get a quarter, right? So 64 is equal to a quarter of h squared. Now we should be able to magnify both sides. So now let's get rid of our fractions. Magnify by 4. I'm going to get what? 256 equals h squared. So I think that's what, 16?
32.
No.
16 squared is 256. So I just figured out my height, and my base would be half that, so 8. Okay. All right. So lastly, take a look at this particular. We saw a triangle kind of like this already. The triangle of interest is the blue triangle in this picture. Remember, these dashed lines don't really exist, but they are there to kind of help us with height and base and stuff. All right. If we are going to try to find x, my guess is that your eyes are going to this, and then maybe also to this. There, base and height. So could we set up a formula for area with those? Okay, so area is 20 times x divided by 2. So area is 10x. Cool. Area is 10x, but I'm supposed to find x. So what about the 10? Can I use some other information in this picture to actually get more detail? So turn your head. What if this, like maybe you turn your head all the way upside down. What if this is your base, and therefore this is your height? You could actually figure out what the area is. Area is 10 times 4 divided by 2. I can use that information to find the area of the blue triangle, which is what, 20 units squared? And then look at that. Wouldn't these be the same? Right? I'm working with the same triangle here, folks. That blue triangle never changed. All I did was I rotated my head, and at one point I called this the base, and then at a different point in the problem I called that the base. So in this case, the area is equal to 10x, so x is 2. So these are the same triangle. Okay. So look for different combinations. That would be my takeaway for you. Look for different combinations of base and height. All right.